Good morning, students. So, uh, from last lecture, we are discussing about basics. Okay, once again, we have started discussing about the basics of VHDL. So, we will continue with that revision in this lecture also. Okay, so I will share my PPTs. But before that, I would like to tell that comment your attendance on that your name in a chat box because yesterday I found though some students were there in a session, but they have not marked their attendance okay in a chat box, and that is why they are marked as absent for yesterday's lecture. So just put your message, name, and roll number in a chat box. Okay, and have a sequence like in the same way, that is a division underscore your roll number underscore your name. Okay, same sequence should be there for everyone. So I'll share my PPTs now. Okay. So in yesterday's session, we discussed till mm, how to write entity. Okay, though we are doing practicals with using this VHDL HDL. So we are aware that what are the different parts in VHDL. So how to write a code in VHDL, that we know, but still for more revision, we are discussing this part. Okay. So in the yesterday's session, we have discussed how to write entities till that much, and then now we are going for the next part. Okay. So I'll skip this part right now, and we'll go for architecture. Okay, of this VHDL code. Now, what is architecture? Architecture is the specification of the design's internal implementation. That means how we are going to design any particular circuitry that will be specified in an architecture. Okay, so what is the internal structure, how we are going to use different gates, or what are the different components that we are going to use, what will be the behavior of each of the output, how it is going to be like that. So that we are going to discuss, or that we are going to write in a architecture. Okay. Now, if we are writing any particular entity, so for that entity, we can have multiple architectures depending on whether we are having a behavioral modeling, or we are having data flow modeling, or we are having a structural modeling. Okay. Now, what is mean by behavioral modeling? In that, we specify that each of the output, how it is going to behave depending on the other input. Okay. So that is the behavioral modeling. So that means actually in that we use truth table. Now, the data flow modeling, that means in that we are using a Boolean expression, and in a structural modeling we are using different components, and that are we are concatenating these components. That means we are combining these components with each other in a data flow modeling. Okay, sorry, in a structural modeling. So here for the depending on this structure, okay, actually whenever we are writing code, so that time we are looking for how it is going to perform, what will be the area that will be occupied by that design, or what will be the power consumption, that means what will be the power dissipation across each of the components in that design, and how easy it is for the simulation. So that all these points that need to be considered while designing any code. Okay, so while writing any code, we need to look for all these points, and then we can write an architecture for that entity. Okay, that means suppose you are considering a hard full wave, full adder. Okay, so whenever you are considering a full adder, that time you can write a VHDL code for this full adder using any one of this methods. That means any one of this modeling style. So here, uh, if you are going for the data flow modeling, then there will be only two statements that you need to write. Okay, so as in a full adder circuitry, we have just two outputs. That is, one is the sum and another one that is a carry. So if you know the Boolean expression for each of these um, outputs, then you can easily write a VHDL code. That means architecture there. Okay, so uh, using that code, which is of very small size, that will be a very easy for you to write a code, and then it will be easier for simulation also, because there will be less syntaxes that will be present in that code, and because of that errors will be lesser. Okay, and so it will be easier for you to write that code. But if you go for the behavioral modeling, then as there are three inputs, that means there will be 8 different combinations for each of these inputs, and then depending on that, what will be the output for sum as well as carry, that you need to decide. That means you need to check for all the truth tables, all are 8 different input combinations, and then for that you need to write a code. So that means it will become a little bit difficult. Okay, but still you that will decide. Okay, now whenever you go for the behavioral modeling, as you are mentioning each and every stimulus there, so that will be performance wise, that will be a very perfect structure. Okay, so depending on what is your goal, okay, what you are going for the performance, or you are going for the area, minimal area, or you are going to reduce power consumption, or you want a easier simulation. Okay, so depending on that, you can go for any one of the modeling style. Okay, then if you look for the architecture declaration, that is specified as, now the keyword architecture, that will be the first word that you need to write, and then there will be a architecture name. Okay, so this architecture name that you need to specify, then this is the keyword of, and then you need to write a entity name for that entity name for which you are going to write this architecture. Okay, then again there will be a keyword, that is a is. Okay, after that there is an architecture declarative part that will be present. Okay, this is the optional. Okay, in some architectures you need to write this. Okay, otherwise uh, you can skip this part. Okay, so this is the optional part, and then again there will be a begin keyword that you need to use, and after that you will have a VHDL statement. Okay, that you need to insert there to assign output, and then uh, you need to write these VHDL statements for each of the output signals. Okay, so that part will be there. Okay, in there, and after that there is a end keyword and then architecture name. Okay, and which will be followed by semicolon. Okay, so remember that in a architecture. Okay, so end of each, in a begin, end of, that means from begin to end, here at end of each of the statement you need to put a semicolon. Okay, so that means semicolon will end that statement. Actually, in other words, we can say like this, की सेमिकोलॉन दिल्यानंतर तुमचं ते स्टेटमेंट एंड होणार आहे, म्हणजे जिथं तुमचं सेमिकोलॉन आहे तिथे ते स्टेटमेंट एंड झालं असं कन्सिडर केलं जाईल. सो प्रत्येक ठिकाणी तुम्हाला चेक करायला लागेल की तुम्ही सेमिकोलॉन दिलाय का, अदरवाईज तो तुमच्या प्रोग्राम मध्ये जेव्हा तुम्ही सिम्युलेट करायला जाल तेव्हा तो एरर दाखवेल. सो यू नीड टू क्लिअरली मेन्शन सेमिकोलॉन at the end of each of the statements. Okay, so this is the आर्किटेक्चर डिक्लेरेशन पार्ट. आता आपण इतक्या वेळा इतके प्रोग्राम्स लिहिलेत, त्यामुळे तुमच्या आता लक्षात आलं असेल की आपण ऍक्च्युअली आर्किटेक्चर कसं लिहितो. सो आतापर्यंत आपण काय बघितलं की VHDL मध्ये आपण काय करतो, तर 3 पार्ट्स आहेत. एक लायब्ररी डिक्लेरेशन, त्यानंतर एंटिटी डिक्लेरेशन, अँड देन देर इज अ आर्किटेक्चर डिक्लेरेशन. दिस पार्ट्स आर देअर. ओके, and then let us see now one example for the architecture declaration. Now you know the simple AND gate. Okay, now in the earlier lecture we have discussed about how to write entity for AND gate. So for the entity, we need a two inputs. Okay, so whenever we are going for the AND gate, we need have two inputs and one output. Okay, when we are considering a two input AND gate, so let us consider that A and B, these are the two inputs, and C is the output. So that part, declaration part, if that is over, so then after this, let us say that this we are going to write architecture. So architecture, then give the name to that architecture. Here it is given as a synthesis one. Okay, now remember that whenever you are mentioning any name, user defined name in a VHDL, okay, it has to be started with a letter. Okay, so that's why this layer name that is started with a letter, that is it. It may have digits also, and it may have a special character, that is underscore. Okay, only one special character, that is underscore, that is allowed in the name. Okay, so here it is a synthesis one. Okay, of, this is a keyword, and then AND gate, that is the entity name is, and then begin. Okay, now here there is no any architecture declaration part that is there. So we have started with a begin, and then C that is assigned to. Okay, this is the assignment statement operator. So that is less than equal to A and B, and then semicolon. Okay, and then end synthesis one. ओके, म्हणजे इथे आपण परत काय करतोय, या आर्किटेक्चरचं एंड करतोय. आता इथे लक्षात ठेवायचं की हे सी हे आपलं काय आहे, आउटपुट आहे. सो दॅट विल आउटपुट विल बी, जिथे आपण करणार आहे दॅट विल बी ऑन अ लेफ्ट साइड, अँड देन देर विल बी assignment operator. Okay, so whatever value that is, or whatever is the result of this expression, that will be assigned to this operator on the left side. Okay, so here this is a C that is assigned to A and B, and then end of this sentence. Okay, so and this is a keyword in a VHDL. So this keyword and denotes it is the use of AND gate. Okay, so this note that is mentioned over here. So and, or, then XOR, these are the some of the keywords that are present in a VHDL. Okay, so now okay, so go just for the this we have discussed earlier. So I'll just go to the data. Okay, so कुणाला काही डाऊट असेल तर मध्येच विचारा, म्हणजे मी आता हे स्किप केलं कारण आपण हे प्रोग्राम मध्ये पण केलेलं आहे. ओके, म्हणजे जेव्हा आर्किटेक्चर आपण फुल ॲडरचा प्रोग्राम रन केला होता तेव्हा आपण ऑलरेडी हे केलंय. किंवा जर तुमची इच्छा असेल तर आपण परतही रन करू शकतो. दॅट इज वाय आय हॅव स्किप्ड इट. बट इफ एनीवन हॅज डाऊट अबाउट दिस दे मे आस्क. कुणाला काही डाऊट आहे का? प्रज्ञा, एनी डाऊट? Shall I consider this as a no doubt?
Yes, ma'am.
Okay, so let us proceed. Now, there are different data objects in a VHDL. Okay, so data object that holds a specific value of a specific type. So, in a VHDL, there are three classes of this data object. One is the constant, then variable, and signal. Okay, so these are the different data or classes of the data object in a VHDL. So this class of the object is specified by a reserved word that appears at the beginning of declaration of that object. Okay, so that is why whenever we are mentioning certain class, okay, so that means when we want any class, that time we mention it as a signal. Okay, so if it is of a signal type, then we mention it as a signal, or if it is a variable, then we mention it as a variable keyword. Okay, so these are the reserved words for that class. So constant, that is an object which is initialized to a specific value when it is created and which cannot be subsequently modified. Constant declarations are allowed in a packages, then entities, architectures, subprogram, blocks, and processes. Okay, so that means suppose any particular data type has the constant value. So in that case, we are mentioning it with a constant. Okay, so we are mentioning class of that data object as a constant. Okay, now we can mention it in a entity. That means suppose we want to declare it in an entity, that we can do, or we want to declare it in a, we can declare it in architecture or processes. Yes. So there we can declare this constant. Okay, the syntax for this constant, that is a constant, this is the reserved word, or we can say a keyword, and then constant name, whatever name that you want to give for the constant, that is specified here. Okay, then if there are number of constants, then you can separate it by column, comma, and then after that there is a colon, then type of that object, and then initial value. Okay, so that value that will be there. Okay, so Here we have some examples, that is a constant s, which is a boolean type, and then the value for that is a true. Okay, so this is the constant. Everywhere it will remain as a same. Okay, जेव्हा जेव्हा तुम्ही constant s म्हणताय तेव्हा त्याची व्हॅल्यू ट्रू आहे असंच कन्सिडर होणार आहे. ओके, किंवा दुसरं एक्झाम्पल आहे की ज्याच्यामध्ये कॉन्स्टंट char 7, which is of a bit vector. Okay, and it is 4 down to 0. That means now as it is a vector, so it has certain range, that is a 4 down to 0. So it is a 5 bit, and then the value for this is a 00117. Okay, now whenever it is a vector, that time when you mention these values you need to put a double quote, as I have explained earlier, and if it is a single bit then you need to specify it with a single quote. Okay, and then here also there is a one more example, that is a constant MSB, which is an integer and having the value that is 1. Okay, so in this way, sorry, having the value that is a 5. So in this way, we can mention this constant. Okay, now if it is a variable, then uh, it is used. These are the variables that are used to hold temporary data. They can be declared in a process or subprogram. Okay, now we cannot mention these in a entity because they are going to vary. Okay, so they should not be mentioned in a entity, but they can be declared in a process because they will be used there only for the particular process only. Whatever is the change in that value, that can be used. Okay, so here this is a variable keyword that is used, then variable name. Okay, if there are number of variables, then they can be separated with a comma. If they are of the same type, then we can write it in this way. So variable, then colon, then type of that variable, and then value of that. Okay, now value is mentioned, assigned is with the operator, that is a colon equal to. Okay, so whenever we are mentioning the value for the variable or constant, we need to assign it with a colon equal to operator. Okay, so here now this is a optional part if you want to mention it, otherwise you can skip this. So variable x comma y, which is a bit type. Okay, so here we have not mentioned the value because this bit type, that means it is going to vary in between 0 and 1 only. Okay, then variable tmp, which is a bit vector with the range 8 down to 0, and variable delay, that is an integer from in the range 0 to 15, and then now initial value that is specified as a 5. Okay, then another class, that is a signal that connects design entities together and communicates changes in values between processes. They can be interpreted as wires or buses in the actual circuit. Signals can be declared in a packages, then entities, architectures, and blocks. Okay. So here, whenever we want to connect any any two inputs or whatever we want to connect in between, okay, so that is done using a signal. Okay, so syntax for this signal is a signal, then signal name, then we say colon type of that signal, and then value, assignment value. So that is the so signal beep is with a separate, here it is a colon, then bit, and having the value that is a 0. Okay, so these are some of the examples for this signal. Okay, now as we have seen earlier, class. Okay, whenever we are considering a class of data object, then we have seen that there are 3 classes. One that is a constant, another one that is a signal, and third one that is a variable. Okay, but at whenever we are mentioning these classes, that time we have to mention a data type. Okay, so that means what is the type of that data, okay, that we need to mention. So all that data objects in a VHDL, that must be defined with a data type. A type declaration defines the name of the type and the range of the type. So type declarations are allowed in a package declaration section, then entity declaration section, architecture declaration, then subprogram declaration and process declaration section. Okay. So data types that include enumeration type, then integer type, then predefined VHDL data type, array type, record type, std underscore logic data type, signed and unsigned data type, and subtypes. Okay, so these are the different types of data. Okay, so whenever you are mentioning any of the data objects, that time you need to mention what is the type of that data object. Okay, so तो कुठल्या टाईपचा आहे हे तुम्हाला पर्टिक्युलरली मेन्शन करावं लागतं and that need to be correctly mentioned because as we are consistently saying that VHDL is a strongly typed language. Okay, म्हणजे काय आहे की प्रत्येक ठिकाणी तुम्हाला त्याचा VHDL मध्ये जो काही डेटा ऑब्जेक्ट आहे त्याचा टाईप हा क्लिअरली आणि करेक्टली मेन्शन करावा लागतो तरच तुमचा एरर फ्री रिझल्ट मिळेल अदरवाइज इट विल प्रोड्यूस एरर अँड दॅट इज अनडिझायरेबल. ओके, म्हणून मग तुम्हाला काय करावं लागतं की प्रत्येक वेळेस तुमचा कुठलाही डेटा ऑब्जेक्ट असू दे त्याचा डेटा टाईप जो आहे तो क्लिअरली मेन्शन करावा लागतो. ओके, आणि जेव्हा तुम्ही असाइनमेंट करता कुठल्याही डेटा ऑब्जेक्टचे दुसऱ्या ऑब्जेक्ट बरोबर तर त्यावेळेस त्या दोन्ही ऑब्जेक्टचे डेटा टाईप हे सेम पाहिजेत अदरवाइज यू नीड टू कन्वर्ट इट टू द सेम टाईप. म्हणजे जरी तुम्ही आधी मेन्शन करताना तुम्ही वेगळ्या टाईपचा असेल तर तो तुम्हाला परत कन्वर्ट करावा लागेल त्याच डेटा टाईपमध्ये तरच ते असाइनमेंट होऊ शकतं अदरवाइज ते नाही होऊ शकणार तर तुम्हाला ती प्रॉपर केअर घ्यावी लागते. सो दीज आर द as I mentioned this list is the different types of data types. Okay. So let us see first enumeration type. Okay. Now enumeration type is defined by listing all possible values of that type. Okay. That means whenever we have written a code of state type machines. Okay. म्हणजे आपण जेव्हा जेव्हा एक्झाम्पल्स बघितले की ट्रॅफिक लाईट कंट्रोलर बघितलं किंवा कॉफी वेंडिंग मशीन बघितलं तर तिथे आपण जे काही जेवढ्या पॉसिबल व्हॅल्यूज होत्या त्या मेन्शन केल्या स्टेटमध्ये. ओके, आणि तो म्हणजे काय आहे दॅट इज द इन्युमरेशन टाईप डेटा. ओके, ऑल द व्हॅल्यूज आर युजर डिफाइंड. ओके, सो दॅट आय हॅव मेन्शन दॅट and these values can be identifier or a single character literal. An identifier is a name such as blue, ball, Monday, Sahi. I can say it as a Sita, Geeta, whatever. Okay, that is the user defined name, and that means suppose I want a list of girls, okay, and boys. So I can say that Sita, Geeta, then Rahul, Raj, or whatever. Okay, so this is the list of the identifiers that can be mentioned in a enumeration type, and all these are the character literals. So all these are the identifiers. Okay, and then character literals that are the single characters that are enclosed in a quote, such as a single quote X, then O. So these are some of the examples. Okay, so here whenever we are mentioning this enumeration type, the syntax for it is a type, then type name. Okay, so whatever is the name that you want to mention, so here it should be. Then again a keyword is, and then the name of this letter. Okay, so that you need to specify here. If there are number of, then you need to mention it, and then end of that statement with a semicolon. Okay, so where type name is an identifier and each enumeration literal is either an identifier or a character literal. Okay. So example of this is a type. Okay. Now suppose I want a color. Okay, I have which will be in the list. So that is a red, orange, yellow, green, blue, purple. ओके, माझ्याकडे एवढे कलर्स जर आहेत तर मी काय मेन्शन करेन की माझा टाइप कलर इज अ then red, all these colors that are separated with a comma. Okay, so as there are these number of letters that are present, so that is a red, orange, yellow, green, blue, and purple. The end of this bracket, and then सेमिकोलॉन. किंवा मी जर म्हटलं डे, ओके, तर डे कुठले कुठले आहेत, तर मंडे, ट्यूजडे, वेनसडे, थर्सडे, फ्रायडे. ओके, ओनली आय वॉन्ट these 5 days, okay, on which I want to work, suppose. Okay, or I have a particular work that need to be performed on these days. So I can mention this. Okay, or suppose I want to mention a state diagram. Okay, so I have different states like S0, S1, S2, S3, S4. So that also I can mention here S1, S2, S3, S4, S1. Okay, so in that way we can define this enumeration type of data. Okay. Then integer type, that is a mathematical integer, and they are useful for counting, indexing, and controlling loops. In most VHDL implementations, typical range is from minus uh, 2147483 to 2147483 Okay, now what is this range? Can you tell? Can anybody tell me? I is the range. So syntax for this type, integer type, that is a type, then type name, okay, and then is a range, and then whatever is the range that you need to specify. So as this is the whole range for this uh, integers, but we need not to use this much range. Okay, जेवढी गरजेची आहे तेवढंच तुम्ही वापरू शकता. So here you can see in this example that is a type count. Okay, so this is the name given to this type. Okay, and is range from 0 to 10. That means it will have these values only. So in that way you can specify this integer type. Then predefined VHDL data type. Okay, so whatever this package that we are using, okay, libraries IEEE that we are using, that has a predefined two type specific packages. One is the standard, and then another one that is the secure in a STD library. So each this contains a standard set of types and operations. So here there are summary of this data type that is defined in the standard package. Okay, whenever we are using std underscore that IEEE underscore std package, okay, so that uses these predefined data types. Okay, so the first is the Boolean and enumeration type with the two values false and true. Okay, so this is the one. If you are saying a Boolean type, then that means it will have two values false and true, and it is used whenever we need to operate certain logical operations or relation operation. Okay, in that case, this it will return to the Boolean value. Then another type that is a bit. Okay, so it is having the values that is a 0 and 1. Okay, then character that is the again enumeration type which is of the asterisk set. Okay, then integer, so it represents positive as well as negative numbers, so that is the integer type. So all these are present in the standard package. Okay, so whenever we want to do uh, certain mathematical operations, that means add, subtract, multiply, divide, in that case we need to use an integer data type. Okay, and whenever we want to do Boolean use certain logical operations or the relational operations, so we can go for the bit type or Boolean type of data type. So another type that is a natural. Okay. So it represents natural numbers, then positive that represents positive numbers, then bit vector that represents array of bit values, then string that is the array of characters, then real that represents real number, and physical type time which represents a time value used for the simulation. Okay, so these are the predefined VHDL data types. Okay, so these are the examples that we have already seen, but still I am mentioning it here. That is the type Boolean is then in a bracket false and true. So that means it is the data type is a Boolean type, so it will have these values, that is a false and true. If type bit is, then it has the values that is a 0, 1. Now as this is the numbers that we are representing here, so it must be mentioned in a single quote. Okay, type severity level, that is a okay. So this is the enumeration type, and then we have mentioned here different types. Okay, so here note, then warning, error, and failure. Okay? So then integer type, then real, character. These are the some of the examples for this data type. Then another type or data type, that is the array type. This array type, that is a group of one or more elements of the same type together as a single object. There are two types of array, that is a constraint array type and unconstrained array type. Constraint array type is a type whose index range is explicitly defined. And then the type of the syntax for this constraint array type, that is type, then array type name is array. Okay, and then range that we need to be discrete range of that subtype indication. Okay, so here array type name is a name of the constraint array type. Discrete range is a subrange of another integer type or an enumeration type, and then subtype indication is the type of each array element. Okay, and then an unconstrained array, that is a type which whose index range is not defined, but index type is defined. So the syntax for unconstrained type array type is a type, then array type name is array, and then type name, if you want to mention, then the range which is in a triangular bracket of subtype indication. Okay, so here example for this is a type A1 is array 0 to 31. Okay, so here this is the range that is a mention of the integer. Okay, then type bit vector is an array which is just a natural. Okay, so subtype is a natural, and range that is not mentioned, that means this is an unconstrained array of bit. Okay, so here then another type is a string which is array of subtype is a positive. Okay, that means all these values in this array, that will be positive. Again, the range is not constraint. Okay, so it is unconstrained. So its range, after that it is followed as a triangular bracket, so of characters. Okay, so here um, this is the array types of data type. Okay, so here are certain examples of this array type. Now let us proceed to the record type. Record type, these are the group or one or more elements of different types together as a single object. The record elements can include elements of any type, including array and record. So type, data type is, then from this, here it is Sunday, Monday, Tuesday. Okay, all these are mentioned. Okay, and then after that, type holiday is, okay, so record, and then here, here it is in the range it is of the type integer, range 19000 to 1999. Then month, that is again integer, range 1 to 12. Day, integer, that is a range 1 to 31. Date, that is a date type. Okay, and end of this record. Okay, so here this is the record type of data type. So here you can have all these different objects in a single record. So this is the example for the record type. Okay. So till here, anyone has any doubt? Yes. Anyone has any doubt?
No doubt, ma'am.
Then another type of the data type, that is a std underscore logic type. Okay. So to model a signal line with more than two values, we can use this type of data type. Okay. So here std underscore logic that has 9 different strings. Okay. So whenever we are mentioning that data type, that is std underscore logic, so it may have 9 different values. U, that means it is uninitialized. Then X, that means it is forcing to unknown. Okay. 0, that means forcing low. 1, that means it is a forcing high. Z, that means high impedance. Then W, that means weak unknown. L, that means weak low. H, that means weak high. And dash, okay, that means it is a don't care. Okay, so these are the different values that can have this std underscore logic type. Okay, so now you must have observed whenever we have simulated certain programs that type, for some of the outputs we are getting initially the value that is used. Okay, that means it is uninitialized because it was not mentioned what we should be the value at particular time period. Okay, so it may have this value. So from this, what we can get, we can have what we can easily realize what will be the value of that data type at particular time period. So this 9 different values that can have this std underscore logic data type. Okay. So similar to this is actually similar to bit and bit vector type. VHDL provides std underscore logic underscore vector also. Okay, so that means it will be a vector which is having all these different values. To use the definitions and functions of the standard logic package, the following statements have to be included in the program. Okay, so what this means? whenever you want to use these data types, that time you need to include this library to your program. Then only you can mention or these data types. Okay. So this is the library IEEE that you need to include or you need to declare in your program, and then you need to add the package that is std underscore logic underscore 1164. That package need to be added to your program. Then another data type, that is a signed and unsigned data type. So both signed and unsigned data types that are declared in the standard synthesis packages, that is a numeric underscore bit and numeric underscore std. Okay, and that is why whenever we have your we have written the program for add shift multiplier, that time we used some more packages. Okay, in a library declaration part, that is a numeric underscore std package that we use. Then we also use the numeric underscore bit package. So because we wanted to use this unsigned data type, okay, we want to operate with unsigned numbers, and therefore we use this package. So remember that whenever you want to use signed numbers or unsigned numbers, that time you need to add not only std underscore logic underscore 1164 package, but this extra packages also, that is the numeric underscore bit as well as numeric underscore std. Objects with unsigned types are interpreted as an unsigned binary integers, and objects with signed types are interpreted as a 2's complement of binary integers. Okay? So this is the syntax for defining all these data types. Okay? So it is a type. Sign is an array of the natural, and then range if it is a constraint or unconstrained, then that you need to specify, and then of bit type or the std underscore logic type. And similarly, it is for the unsigned. Okay, so this you can see here. These are the different packages that is added in this library. So then there are certain deep subtypes that are provided by VHDL, which are defined as a subset of other types. So anywhere a type definition can appear, a subsystem definition can also appear. So natural and positive, these are the subtypes of integers, and they can be used with any integer function. Okay. So this is about the different types, data types, VHDL. Okay. So we have discussed about these different subtypes. Okay, so in an examination there may be questions like explain different data types in a VHDL. So in that case you need to explain all of these data types with a example. Okay, so that will be the question. Okay, so if anyone has doubts, they may ask. लक्षात आलंय सगळ्यांच्या इथपर्यंत? ओके, ऑलरेडी आपण जेव्हा प्रोग्राम लिहितो तेव्हा तुमच्या लक्षात आलं असेल की कारण आपण थिअरी खूप बोललो तर ते बऱ्याचदा लक्षात येत नाही.